right, so the 7th unit is looking at simple harmonic motion and oscillations. And so our 7.1 notes is looking at the word oscillation. Now this word just means motion that is going to repeat over and over. It's going to be that repetitive motion. So it is motion that repeats over and over between two endpoints. This is a type of periodic motion. So this is periodic motion. So that means that if you were to map out periodic motion over time, that it would repeat over and over. It would be the same. Now, we have something called simple harmonic motion, often abbreviated as SHM, simple harmonic motion. Now, that is a type of periodic motion, but simple harmonic, I'll write it over here. Simple harmonic motion is going to be that repetitive motion, but it's due to some restoring force that's proportional to its displacement. So it's a type of periodic motion due to a restoring force. Proportional to displacement. Now, this is what we are going to actually focus on, our simple harmonic. And this motion is going to kind of focus in on a wave. It's going to have several properties that are easy to define and are going to be useful in helping us figure out different mathematical things. So the first question here says, if we let periodic motion stand for PM and we let simple harmonic motion stand for SHM, which of these diagrams is correct? Well, I said that it is a type of periodic motion. So periodic motion is going to be kind of that umbrella term, and simple harmonic motion is a type from that. So they are not different quantities. They are not completely separate. They are not the same thing. But simple harmonic is a subset of periodic motion, which means that the correct answer has to be diagram B. So it is a type of periodic motion. The next thing is kind of using some terms that we're going to be using throughout this section, throughout this unit, that have very specific meanings. And that is endpoint, equilibrium, and amplitude. Endpoint is going to be when an object stops or it reverses direction. Object stops or reverses direction. So if you think about the two most common examples of simple harmonic motion, that would be a pendulum or a spring. If you think about an object as it's oscillating on a spring, that just means as it's moving back and forth. It will reach this maximum place, it will stop, and it will change direction, and it will come back towards you. That point that it changes direction is called the endpoint. The next thing that we have is the equilibrium position. Equilibrium, we have talked about this word pretty frequently. Equilibrium means that everything is balanced. So it's a place where there is no net force because the forces are balanced. That's your equilibrium position. And then the last thing that we have is the word amplitude. Amplitude is maybe different than these two because it's not in a specific position. This is a location. When I'm dealing with amplitude, that's going to be an actual measurement. And it is the distance from your equilibrium to an endpoint. So if you think about a spring as it's oscillating back and forth, it's going to move left and right like this. When it is at its equilibrium position, that's when the string is not being stretched or compressed. That's your equilibrium. When it is pushed as far back as it can go, that is an endpoint. And if you want to measure the distance between them, that is your amplitude.